In this section, we will talk about how Semidynamics customizable vector unit for RISC-V can support various data types, vector lengths, and vector cores. This vector unit is one of the first in the industry that is compliant with the RISC-V Vector Specification 1.0 and offers a high level of flexibility and performance for applications such as AI, HPC, and GPU. A vector unit is a component of a processor that can perform multiple calculations in parallel using vector registers. Vector registers are special registers that can store multiple data elements of the same type. For example, a vector register can store 4 32-bit integers or 2 64-bit floating point numbers. By using vector instructions, a processor can operate on all the data elements in a vector register at once instead of processing them one by one. This can greatly speed up computations that involve large amounts of data, such as matrix multiplication, image processing, or neural network inference. Semidynamics vector unit is composed of several vector cores that each have their own arithmetic units and vector registers. Each vector core can be customized to support different data types, such as FP64, FP32, FP16, PS16, INT64, INT32, INT16, or INT. The data type determines the size of each data element and the operations that can be performed on them. For example, a vector core that supports FP64 can perform floating point arithmetic on 64-bit numbers, while a vector core that supports INT8 can perform integer arithmetic on 8-bit numbers. The number of vector cores in the vector unit can also be customized according to the needs of the application and the trade-off between power and performance. Semidynamics offers options of 4, 8, 16, or 32 vector cores per vector unit. The more vector cores there are, the more parallel computations can be done in a single cycle. However, this also increases the complexity and power consumption of the vector unit. Another feature that Semidynamics offers is the customization of the vector register bit size, VLEN. The VLEN determines how many data elements can be stored in a single vector register. The standard VLEN is equal to the total data path width, DLEN, which is the product of the number of vector cores and the size of each data element. For example, if there are 8 vector cores that support FP32, then DLEN is 256 bits, and VLEN is also 256 bits. This means that each vector register can store 8 FP32 numbers. However, Semidynamics allows customers to choose a larger VLEN than DLEN, such as 2x, 4x, or 8x. This means that each vector register can store more data elements than the number of vector cores. For example, if VLEN is 4x DLEN, then each vector register can store 32 FP32 numbers. Instead of this can increase the amount of data that can be processed by the vector unit in a single instruction. However, this also means that each vector instruction will take multiple cycles to execute, since not all the data elements can be processed by the vector cores at once. This can help manage memory latencies and reduce power use by spreading out the computations over time. Semidynamics customizable vector unit for RISC-V provides a powerful and flexible solution for applications that require high-performance parallel processing. By allowing customers to choose the data types, vector lengths, and vector cores that best suit their needs, Semidynamics enables them to optimize their processors for their specific domains and workloads.